kernel. The kernel is the most important part of an operating system. So what the kernel does is, the kernel is responsible for the for low-level tasks like disk management, communication between the hardware and the user space. Right? If hardware, the kernel provides that functionality. Like, let's say the kernel is the middleman. Let me say the kernel is the middleman between the hardware and the user space. I can right say that. And the way the user space communicates with the kernel is with system calls. I don't know if anyone has taken that operating system calls here. So when doing operating system calls, there's what we call system calls. System calls is like how the user space communicates with the kernel. So we have different system calls. There are different system calls for different operating systems, like Windows and stuff. So we have, I'll show you what the system call looks like. So about the Linux kernel. Linux kernel is monolithic. Windows and Mac, they are hybrid kernels, while Linux is monolithic. There was given an argument between Linus Torvalds and one of his professors on why he says Linux is like that the architecture for Linux is not really fitting. That it would have gone with a microkernel architecture and stuff. But so far, Linux being monolithic is one of its strengths today. So the Linux kernel is also modular. So modular in the sense that you can load in drivers. Have you wondered why? I don't know if anyone uses Linux yet. Have you wondered why you can make upgrades and make updates without restarting your system? Yeah, that's because it's Linux kernel is modular. So when the Linux kernel, for some reason, it can't put or something, so it panics. I think in Windows it's called blue screen update. Yeah, Windows is called blue screen update. So, though this is not an open source 101 class, but you just have to look at what open source is. So, open source is something that people can modify and share because its design is publicly accessible. Yeah, so it's self-explanatory, right? Yeah. So, here we go. The development process of the Linux kernel. So it's something that happens every day, 24 hours a day, 7 weeks, 7 days a week, and 365 days a year. So there's always development on the Linux kernel. What's wrong now? Okay, so there's always development on So there's always development on the Linux kernel. I don't know why this side is a bit funny, but let's continue. So there's always development going on, and this results in a new release of the Linux kernel every 2 months plus. So every 2 months plus is a new release for the Linux kernel, and several stable and stable kernels are released. So right now, I think we're in 5.16. 5.16 kernel has been released. So let's say Linux Torvalds releases the 5.2 kernel. So once he releases that, there's a merge window. So what the merge window is open. So during the 2-week merge window, developers send their patches to the maintainers. That there are a set of people called maintainers that maintain the Linux kernel. So these developers send their patches to the maintainers, and yeah, the Linux how do I say this now? Linux doesn't use maybe the way you are familiar with going to Github, forking the repo, and opening a pull request or something. It doesn't work that way on Linux. So on Linux, you have to make your changes, generate a patch, and set that patch to a maintainer. Then the maintainer sends that patch to the installers and is the one who is going to do the final merging. So during the 2-week merge window, you send your patch to the maintainers. And yeah, during that time, after the merge window closes after 2 weeks, so there will be discussions on the patch sheets that the developers sent. So if any regressions and everything, they'll fix bugs and everything begins. So at RC means release candidate. So I think I should just go in here. Okay, so this is how it works. From developer to maintainer to the installers. Developer to maintainer to installers. So he's the one that has the final say. He's the one that manages everything into the Linux kernel. So this is how it goes. Like I said, let's say 5.3 was released, 5.3 stable kernel was released. This is 1 week after September 30. This was in 2019. This was in 2019. This happened in 2019. September 15, 5.3 was released. And September 30th, that was 2 weeks later, an RC1 will be released and the merge window is closed. Remember, the merge window is open for 2 weeks immediately after a stable release. So when that merge window is open, a release candidate 1 will be released, and these release candidates are not available to normal users, or let me say, you can't get this unless you have to go to the repos, you get the code and compile it. You can't really get this. Okay, I was trying to play a game on Amazon EC2 server. So it's called Ambox. There's an emulator called Ambox. So I don't know. The kernel I was using then was, I think, 5.3 or 5.4, and it did not really have the Ambox driver. So I just had to get I checked around and I saw that it's in development. So I just had to get one of these pre-patch kernels, compiled it, and I got the driver I'm looking for. So stable kernels are released on average once a week and as a needed basis. So long-term kernels. I don't know if you have seen something like LTS, maybe when you are trying to download Ubuntu. Yeah, Ubuntu LTS. So LTS means long-term support. Yeah, so long-term kernels are kernels that are selected for long-term maintenance to provide critical bug fixes. So an example of a long-term kernel was 5.10. This is the latest LTS kernel, 5.10. Like I said, right now we're in 5.16. The latest Linux kernel should be 5.16 or 5.17. So this is the versioning of a Linux kernel. So just give me a second. If you use Ubuntu, you see Ubuntu. If it's AWS, you are going to see AWS. Or if it's Kali, you see Kali. Building and compiling the kernel is CPU intensive. It's not really memory. So I don't know. Just have a very good CPU and maybe 8 GB RAM or anything. So the needed tools. I have a Github Repo. I don't know if I can share that. Maybe I'll share that on my Twitter. So I have a Github Repo. You just have to run a script called check.sa. It's going to check your system for the tools you need. There are some tools you need to build and compile the kernel. Huh? So there are tools you need to. There are tools that you need to compile and build the kernel. Tools like GCC, Bison, and the rest. So that's my Github Repo. You just run this script. It checks your system for the needed tools. If it is there, is going to install the tool for you. So you configure the tools and use a make line. Like I said, you send your patches via mail. You send your patches to the maintainers via mail. Nothing is done on the like pull request or anything. So everything you send these patches via mail. And you can use a make lines like mute or git mail. So mute is like a terminal user interface. A mail terminal user interface. So you can use mute. Yeah, but don't also try to send your patches like as an attachment on Gmail. It doesn't work that way. So using an attachment is as if you are sending a file. So you have to use send the patches as a header body. So explain the kernel sources. Yes, this website called Credit. You can just check it online, Credit. So it gives you an overview of what the Linux kernel has gone through years and by. So you see what's happening, where much of the code lives and everything. So yeah, these days most of the development in Linux kernel goes on in the driver section. If you check Credit, the driver folder is full with a lot of code and everything. That's where most of the code in Linux kernel is. So you can check Credit, and you can also check the history of source files. If you want to see this, you can use GitLog and the commit ID, and you get the history of a source file. The mainline kernel, like I said, RC, those RC, you can check the GitHub directories, and you see this there, the mainline kernels. It depends on what you want and stuff. So you can just try to explore the directories. There are some directories like Arch, driver section, and the rest. So installing and compiling a kernel. So you can get a stable kernel that you don't want it to break, especially when you're trying to compile. So you configure the kernel. Now, if you go to your Linux distro, that's the boot/boot. There's this file called .config. So that file is like gives the Linux. Who has heard of make? Make is a Linux tool used to generate source file for compilation. Yeah. So that file .config gives you Linux kernel and gives make an idea of what your system is like. So you avoid bloating your system with drivers and features that you don't need. For example, now let me say you're on a server, like a web server or something. That tells you that you don't need a video driver, right? So configurations like this, you avoid bloating your kernel. So you try to boot the kernel. This is quite dangerous. Okay, you compile and install the kernel. This takes about 2 hours to compile and successfully install a kernel. So if you are trying this out and maybe you didn't get it, you can just reach out to me. I'm booting a kernel. Yeah, it's one of those dangerous stuff. I've spoiled my system many times trying to boot a kernel, like many times. Because if you don't do this well, especially if you use Grub, like Grub is a bootloader for Linux. So especially if you use Grub, you have to make some certain kind of configuration, and you should also have you should not delete your old kernel, so that in case the new kernel fails, you can boot with the new kernel, old kernel, sorry. So writing a kernel patch. So this is exactly how it goes. So let me say make a change to a driver or something. You compile and test if it's working. So you run checkpatch.pl. When you generate the patch, run the script against the patch. Check if you go to the script directory on the Linux kernel, like a Linux source. There's a script session, a script folder, and check.pl is there. So once you get that, you have to check to see if everything is okay with your new code, the code that you make everything. If it's not okay, you get it gives errors and so you just fix them and stuff. So there's also another script called get maintenance also. So when you run that script against your patch, it's going to tell you the maintainer you're supposed to send your patch to. So when sending this patch, don't only send the patch to the maintainer, also send it to the mailing list. And you fix the errors and one patch res, repeat that stuff. So these are the steps of writing a patch. Create a new branch, commit your change, generate patch. You can generate patch with git format patch, I think. Git format patch. You run check patch.pl, check the patch. If everything is okay with it, run get maintainer.pl. So you have the email addresses of the maintainer and the mailing list you are supposed to send that patch to. And you send the patch. Like I said, send your patch to the mailing list and also send it to the maintainer. So this is the life of an open source developer. Become a window shopper, trying to look at how things goes. Silent observer. You become a contributor. You can be a contributor, be a tester, be an active contributor, expert and maintainers. So this is essentially the life of what an open source developer is. You can't really just jump into a community and try to say, okay, I want to do this, I want to make these changes, I want to make these changes and stuff. Just try to observe how things are going. And yes, the people in the Linux kernel, they are not nice people, they are very wicked people. That is just the truth. They are very harsh people. They are very harsh people, that is just the truth. So try to be respectful and also try to put a lot of descriptions in the patch you are sending. Try to put a lot of descriptions and they can be rude sometimes, but just try your best. We all have different cultures and everything, so just try your best to do that with them. So contribute your quota today by contributing to the Linux kernel.